Good morning. I'm Sarah Rickman, and today I am interviewing Erin Young. Erin leads the aircraft systems team comprised of flight controls, landing gear, hydraulics, propulsion, and environmental control systems for the XB-1 Supersonic demonstrator. As the 10th employee, she has seen Boom through critical development stages in their mission to bring back commercial supersonic flight. Previously, Erin designed flight control systems for the Scorpion jet at Textron Aviation. She holds a BS degree in aerospace engineering from the University of Notre Dame. Outside of work, Erin has held various leadership positions in the Rocky Mountain section of the Society of Women Engineers. She leads STEM events through SWE and at Boom for students in the community to learn about aerospace and aviation. Inspiring young women to consider engineering as a career is something she is very passionate about. Additionally, Erin holds a private pilot certificate and enjoys taking breaks from the office to get into the sky. She is with Boom Supersonic, and today, Erin, welcome.
Thank you so much for having me.
Let's go back in time. What did you want to be, and what did you want to do when you grew up?
So when I was a small child, I was very interested in reading. I read everything all the time. Reading was my passion. So as I got into middle school and eventually high school, I thought that creative writing would be a fantastic field for me to go into. I loved writing short stories, poetry, all sorts of things in my free time. I would enter different contests for writing samples, things like that. So I really thought I had it figured out what I was passionate about and what I wanted to do. All that sort of changed when I was 13. As a seventh grade girl, I had the opportunity to spend a week at space camp at the Cosmosphere in Hutchinson, Kansas. And space camp changed my whole view about my future and what I wanted to be. I'd always been interested in airplanes to the extent of I thought they were very cool. I loved when we got to fly different places to visit family or friends. And so there was something about them that interested me, but it wasn't something I had pursued. In that week in space camp, I went through their astronaut training program, did everything an astronaut would do to prepare for a mission, and eventually got to end the week with flying as commander of the space shuttle on a simulated mission. It was the coolest week of my life. And leaving space camp, I realized, man, I really want to be an astronaut. This is what I want to be when I grow up. I care about this a lot more than writing. And it was finding my true passion in that week, I think. The problem was that I have two lawyers for parents, and while they were very supportive of my interests, they really had no idea how to direct me into what someone would need to do to become an astronaut. In fact, engineering was not something anyone in my family had ever done, so it wasn't something that was talked about often as a potential career path. Fortunately, junior year of high school, which is pretty late, I had a career counselor talking to me and understanding that my interest was in space and potentially becoming an astronaut at some point in the future. And she said, have you ever thought about aerospace engineering? And up to that point, I thought, okay, maybe I should study astronomy because that has to do with the stars and astronauts fly among the stars. It was just not a very informed path to be going down. So I started looking into aerospace engineering and ended up declaring that my major at Notre Dame. And I'm so glad that I did. As I started taking more classes, I realized this was really what I was supposed to be doing. The aviation classes in particular really spoke to me. So until about junior year of college, I thought for sure I would go into space engineering. I would work for NASA or I would work for SpaceX. And I'd work towards that goal of being an astronaut. But what I realized was that I was fascinated by the aviation side of aerospace. How do aircraft fly? How do you control them when they're in the sky? There's so many interesting things about an airplane itself. And so I started going down that path a little bit more and looking for jobs in the aviation industry and not just space. When I graduated, I was fortunate enough to join Textron Aviation. I worked as a Cessna employee initially. And in that time, I worked on a rapid prototype development, the Scorpion jet. So it's an aircraft that went from a clean sheet design to first flight in just 22 months, which is very fast. That meant that when I joined, they were about 6 months into the program, or sorry, a year into the program. And my second week at work, I was helping hang flaps onto the wing. It was very hands-on. You learned a lot very quickly. It really solidified for me that I was in a field that was very exciting, and it was something that I cared about and was excited to keep learning about too.
Let's follow that a little bit further then with talking about Boom Supersonic, your current employer, and how did all that happen?
Sure. So I'll talk a little bit about how I found out about Boom and then what Boom is. While I was at Cessna working on the Scorpion jet, I was a Cessna employee, and they have a fantastic employees flying club. So in high school, when I started exploring this aviation interest, I talked to my parents. I brought them this full report I had looked up of here's how much it's going to cost for me to become a pilot, and this is why I should be allowed to do it. That was shot down pretty quickly. But once I graduated college and I had a job and I had my own salary, I could make the choice that this was something that I wanted to pursue myself. So I joined the Cessna Employees Flying Club, and I trained to become a private pilot in a 172 aircraft. It was one of the best decisions I could have made, not just because flying is such a great hobby, and it's so much fun, and you meet interesting people and you learn a lot while you're doing it, but it's also made me a better engineer overall. So I have a better appreciation for the customer of the aircraft, the pilot, what they need to think about and understand and what they expect from the aircraft that they're flying in. So when I went to design flight control systems, it's a much better perspective if you actually understand what the end user is thinking about when they're operating your system. My flight instructor, though, is the one who introduced me to it, who ended up hiring me at Boom. So the hiring manager at Boom asked my flight instructor, they were friendly from way back in their past, if he knew anyone who knew flight control systems. And Tony, my instructor, was able to say, yes, I just finished training a girl who does. So I got a call from one of the early Boom employees with this crazy story about bringing back commercial supersonic flight. There wasn't really any of this happening in the industry at that point, or startup companies in aviation. Obviously, we had SpaceX and Elon Musk pursuing a startup company in the space sector, but aviation didn't have a lot of this going on. So I was fairly skeptical. But I agreed to do the interview because I was interested in a brand new area of engineering and development in the aviation industry. At the time, the company was about 6 people. So I interviewed in our CEO's basement out here in Denver, Colorado, which was a very interesting experience. But I ended up really believing all the things he said about how Boom was going to change the future. So a little bit about Boom. What we want to do is make the world a smaller place overall. We want to connect more people to more places, to more cultures, to allow them to make business trips faster so they can get back home to be with family, or to visit friends who are across oceans that they never get to connect with. And our approach to doing that is to bring back commercial supersonic flight. Supersonic flight means flying faster than the speed of sound. So we will fly fast enough that a flight from New York to London would be about 3.5 hours instead of 7. Or a flight from San Francisco to Tokyo would be about 6 hours instead of 11. These are huge differences in time that can make meaningful impact on people's lives. Our flagship aircraft is the Overture aircraft. It's designed to be an industry-leading aircraft in terms of speed, safety, and sustainability. It'll be able to hold about 88 passengers when we first bring it to market. Right now, what we're working on, though, is our XB1 supersonic demonstrator. And that's letting us test supersonic flight systems, design, and technologies that we've come up with before we put them on the commercial aircraft. So the XB1 demonstrator is about 1/3 of the scale, similar to the size of a fighter jet, like a T-38 or an F-5. And that's the aircraft that I'm working on now. It's at a very exciting stage in development because we have done quite a few engine runs on it, and we're getting ready to send the aircraft into its first flight.
I remember the Concorde. and I believe it was the first supersonic passenger plane. And the rest of my question, I think you've already answered. What has Boom Aviation followed somewhat in the footsteps of the Concorde? Tell me more, please.
Sure. So absolutely, the Concorde is something that we can draw a lot of inspiration from, especially in terms of bringing supersonic travel to the commercial market. They had a lot of talented engineers who've inspired us to make that dream a reality again in modern day aviation. But for all that it achieved, it still had a lot of things fighting against it. It was very expensive to operate due to high fuel costs. The aircraft flew with afterburning engines, which burns a ton of fuel. So because of those very high fares, it was really difficult to fill the aircraft when it was flying, which meant that it was never used for routine travel. It was really a one-off experience. And that's not something that everyday people can end up taking advantage of. So what Boom wants to do is learn from Concorde and take advantage of all the developments in technology since then and make an affordable and efficient commercial supersonic aircraft.
That brings us to sustainable aviation and sustainable fuel. So bring us into that phase of it now, because that's where we're all hoping to head, and I know that's your goal. So sustainable aviation, please.
Absolutely. So since Boom was founded, it's been driven by three key principles. It's speed, safety, and sustainability. And we need all three of those to be successful in order for the company to be successful. We fundamentally believe that travel is good for humanity, and allowing people to connect more often in person, more easily, is good for the world. But we want people to travel without the adverse effects on the environment. We want to be very conscious of that as well. So in order to do that, to get people to travel more places more often, we need to tackle the environmental challenges associated with travel. So we challenged our whole engineering team to come up with an environmentally responsible supersonic aircraft. What that means is that Overture, our flagship aircraft, will be able to operate on up to 100% sustainable aviation fuels, or SAF. So unlike current Jet A fuel used on aircraft, which is made from fossil fuels, SAF does not need to be pulled from the ground to extract the crude oil. So it can actually be, the carbon for it can be made from materials like used cooking oil or forestry and agricultural waste, or even fast-growing plants like algae. So there's a lot of options for us to make a cleaner future as we're making a more accessible world. And that's something that's very important to us.
So can you tell us a little bit more of your concept of our future with this clean and supersonic aviation?
Sure. So to touch on how our aircraft is going to learn from the past and be a different, more efficient aircraft, there are advancements in technology that we definitely want to take advantage of. And since the Concorde days, there's been 60 years of engineering that we can incorporate into our designs. So some key areas that exists are in the CFD aerodynamic design part of the aircraft, in the materials that we use, and then in the engine technology. And the engine technology is the biggest part of the sustainable future. But starting with CFD, CFD stands for computational fluid dynamics, and it's used to design the exterior loft of the aircraft or the shape of the aircraft. When you're flying really fast, being very efficient is incredibly important to keep fuel burn down and then to keep costs down. And so we want to make sure that we are making an aircraft with as little drag as possible. So there's little resistance to it flying. When the Concorde was designed, they didn't have access to technology like CFD. So every iteration that they worked on, they had to take to a wind tunnel. And that cost millions of dollars into months for every iteration. Because of that, they only ever tested 11 planforms, which is not very many. We can test thousands of them in computer simulations every week. So we can really hone in on what is the most efficient shape for this aircraft so that we get the most fuel efficiency possible. So that's the first area. The second one is in materials. The Concorde was also built from metal. It's aluminum. We have carbon fiber technology now. And so when it comes to making those shapes that are very fluid and very efficient, shown in the CFD, metal doesn't really want to form into those shapes as well. It's not as pliable. But carbon fiber composites can actually be molded into the exact shape and structure that you want for your aircraft so that you fully take advantage of that efficient design that you've come up with. And then the last one is the engine technology. I mentioned it before, but when Concorde flew, it was flying with afterburning engines. When you fly with afterburners, you inject about 70% more fuel than you would with a non-afterburner engine. That's a huge increase in fuel burn and therefore cost to operate the aircraft that gets passed on to the users, the passengers. So we can take advantage of modern turbofan technologies and still meet our supersonic flight targets, but without needing to use an afterburner to fly. And that's just based off of the years of improvement in efficiency in engine technology. So we've come a long way since the days of the Concorde.
What have I failed to ask you, and what can you help us with?
That's a good question. I think there's one other interesting change from the Concorde to our aircraft that really shows how far we've come in aviation technology. If you Google a picture of the Concorde, you will see, or the Concorde landing specifically, you'll see a picture of an aircraft coming in to land. And then you'll see the nose of the aircraft is actually drooped over. And it looks really silly as it comes down to land on the runway. The reason for that, though, is pretty fascinating. When you design a really sleek, narrow, efficient aircraft, it's very efficient at supersonic speeds. It wants to fly fast, but it doesn't like flying at those slow speeds that you need to be at to come into land. It just doesn't have the same lift capability of like the aircrafts that you fly out of an airport today. They've got these huge wings. We've got very, very narrow ones on a supersonic aircraft. So you actually have to stay at a high angle of attack to maintain lift on the surfaces of the wings that are so small as you're coming down to the runway. When you're at that high angle of attack, if you picture a pilot in the cockpit, he can't see where he's going. So in a supersonic aircraft, you actually have a hard time with visibility to the runway in a very critical phase of flight like landing. So the Concorde solved that problem in a really kind of brute force way. And it's a cool piece of engineering, but it's not very efficient. They actually mechanically put a hinge in the cockpit of the aircraft so that the whole cockpit nose can droop down and allow the pilot's visibility to the ground while they're coming in to land. So you end up with a really goofy looking aircraft that was very effective. The pilots could see and they could get on the ground safely. We don't want to take that approach in our new aircraft because while it's a cool mechanical design, and as an engineer, I can very much appreciate it, it's very heavy to put something like that in an aircraft. And weight matters a lot. Weight goes back to how much fuel we have to burn to fly fast, and therefore how efficient we are and how much our tickets will end up costing. We want everyone to be able to afford flying on an overture aircraft. So instead of taking that mechanical approach, we're using cameras, the modern technology of putting actual video feeds directly from the nose landing gear of the aircraft looking down the runway up into the cockpit for the pilot. So that the pilot can actually have runway visualization without moving any physical part of the aircraft at all. So it's just another way technology is helping us make a more efficient supersonic future.
That's amazing. Okay. I basically have one other question to ask, and I'll let you take it from there. Okay. And this is an interest that both of us we share. What do you want to say to young women in particular about a potential for a future in clean, sustainable aviation?
I really love this question because I think one of the ways that we can get more women, and especially young women, interested in a career in aviation is to provide them with projects and missions that they can be very passionate about, and they can care about the impact that their work is having on the world, on people in the world, and on our environment as well. When I graduated school, there were few projects that really grab you in industry from that perspective, that made you very excited about the impact that you could have on the world? There's a lot of minor modifications happening to aircraft to make them more efficient. There's not a big mission that's going to really shake things up and change them. That's why I was so excited when I found Boom, and excited about joining this company. I found a project that I am incredibly passionate about, and I feel like I can put my aerospace engineering degree to good use in making the world a more accessible place for people, which can fundamentally change their lives and how they operate in the world. And we can do it while focusing on keeping our environment healthy and on a clean future for everyone. So I'm very excited that there are now projects out there, even if competitors to us show up. That's actually great for the future of aviation and getting more women into the field as well. I want to see there being a lot of projects that women can show their passion in and really take on and solve tough problems in the world. So I think that the future of the industry is very exciting, and I'd like to share that with as many young women as possible. And hopefully I'll be working alongside of a lot of them in a few years.
That gives me one other question.
Sure.
It's kind of back to the nitty gritty. For these gals, these young gals in middle school, probably now, who are heading for high school, what should they be looking at in order to qualify for the ultimate college education that will take them into employment in a place like Boom Supersonic?
It's a great question, because it's something that I wish someone had talked to me about when I was in middle school or in high school. I feel like I kind of learned that a little bit late. To be completely honest, I hated math in high school. And that's like a pretty fundamental part about being an engineer. But I think what really matters is the teacher that you have in those courses can really make or break sometimes how you feel about them. What I would say is, don't let that influence which major you end up thinking about for a college education. I think an engineering degree can be a fantastic choice no matter where you want your future to go. We have engineers working in every possible industry that you can imagine. There are also engineers who go to med school or who become lawyers, who do things not even in the engineering field once they graduate. But engineering teaches you a way to think and to problem solve that is really useful no matter what you want to do. Mainly, though, it can give you the tools that are required to work on the projects that are going to change the world and change the future. So I would recommend considering an engineering degree and focusing on those math courses, even when they're painful in high school. I thought they were too. Chemistry is pretty fundamental to that as well. But once you get past the kind of foundational courses, you get into the much more specific courses to your engineering major. So the first few years, if you don't know which engineering specialty you want to be in, that's okay. There's fundamentals that everyone has to take. By like junior year, you're becoming more specialized. And for me, that was the most exciting part of college, because I got to take aviation and aerospace specific courses. So you have some time to figure it out too. I highly recommend getting involved in clubs and organizations outside of classes that allow you to be very hands-on, that build projects like Design, Build, Fly lets you build an aircraft, a remote controlled aircraft, or the rocket clubs allow you to build a rocket to launch. Those sorts of things give you a hands-on experience that helps you figure out what you really love and what you're passionate about, and sets you up for industry in a way that just courses don't. So that's a big recommendation of mine, and something I wish I did more of.
Great. Oh, that's a great answer. I enjoyed hearing it myself. And knowing I've been there too, like, okay, now what do I do? I wish I had more direction. I greatly appreciate it. The 99's Museum of Women Pilots appreciates it. Hey, since we both live in Colorado, I hope we meet sometime.
I hope so too. That would be fantastic.
Okay. Thank you. Appreciate what
Thank you so much. Yeah.